Hello, good evening. Any doubt from last class? Atif? Okay, so tell me the last topic, what we did in last class. Abhinav?
Good evening, sir.
Good evening. Tell me the last topic, what we did in last class.
Sir, let me check my notebook, sir.
Okay. Atif? What we're discussing last class?
1 minute.
Just 1 minute. Yes, Atif. I think we did thermal properties of matter and thermodynamics. Okay. Let me define you mechanical properties of solid and fluid. Atif, we did this particular part in revision or not?
Yes, sir.
We did mechanical properties of solid in revision or not?
No, sir, it did not do.
Okay. In solid, mechanical properties solid. There will be question on different types of stress, strain, and Hooke's law. So you will be asked to define first, what do you mean by Hooke's law? Next question will be, suppose if you have to define bulk modulus, that is volumetric stress divided by volumetric strain. Suppose we have three different states of matter, that is bulk modulus of solid, bulk modulus of liquid, and bulk modulus of gas. So how these three different bulk modulus will be related with one another? So we say this is related like this. Is it clear?
Yes, sir.
Next question will be, you will be asked to define which is more elastic. Like in pair, suppose steel and rubber. Suppose water and gas. So how will you define which is more elastic? Let me define you for the first part.
The steel.
How you can define mathematically? Take equal segment of both these two different parts. Suppose we have equal dimension of rubber and steel joined to any fixed support. So if you apply any deforming force to these two different objects, let's say this one is a steel and this is for rubber. In which case do you think there's more elongation, in case of steel or in case of rubber? Atif? Yes, Abhinav?
In steel.
On applying same force, there will be more elongation in steel. No.
On same force.
Yeah.
Rubber, sir.
Yes. Good. We have same dimension of both these two body, having same length, having same area of cross section, and same force is applied on both of them. So you'll say there will be very small amount of deformation in case of steel, but there will be large amount of deformation in case of rubber. As Young's modulus is equals to force times length divided by area of cross section times change in length. So force is same, length is same, and area of cross section is same. So Young's modulus is inversely proportional to change in length. Since in this part, delta in rubber is greater than steel, therefore Young's modulus of steel will be greater than Young's modulus of rubber. Hence, we can say steel is more elastic as compared to rubber. Is it clear?
Yes, sir.
Similarly, if you have to define for second part, water and gas. So you'll say take equal volume of both these two. Suppose in a balloon, this is gas and this is in case of water. So if you apply same amount of pressure on both of them, in which case do you think there will be more compression? In case of water or in case of gas?
In case of gas, sir, there we can compress more.
Good. So we can say change in volume in case of gas will be more as compared to change in volume in case of water. So from this part, bulk modulus is inversely proportional to volume,
Delta V.
and change in volume in case of water will be lesser as compared to gas. Therefore, bulk modulus of water will be more as compared to gas. Hence, water is more elastic as compared to gas. Umar, is it clear? Okay. Next question will be on the basis of stress strain curve. Stress strain curve. You'll be asked to define stress strain curve, different point, and from that curve, you'll be asked to point out some points like define yield point. Next, elastic limit. Next, breaking point. Ultimate stress. These different things. Suppose let's say this is first point A, further to point B, further to point C, and further to point D. Which one is yield point?
Yes, sir.
A. Elastic limit?
B, sir.
Oh, good.
And
Breaking
breaking
point?
point is D. Ultimate point is C.
Oh. Atif, tell me.
Sorry, yield point is A, elastic point is B, then breaking point is
Just
C, and
1
ultimate
minute.
stress is D.
Just 1 minute. Yield point is a point up to which object shows some elastic behavior. So I defined you the class. Suppose if you stretch this particular object up to point A, and if you remove deforming force, it will retrace its original path and comes back exactly to its own configuration to this. It means within this particular range, it will have tendency to retrace its original path exactly. Next, if you extend it up to B, and if deforming force is removed at this point, that will have tendency to return back, but with some permanent deformation with it. This is called permanent set, which is about 1 to 2% of its actual length. But for further elongation between B to C, there is no elastic behavior to this particular substance. So up to point B, object shows some elastic behavior. That's why this B point is called Yale point. Atif, is it clear?
Yes, sir.
Elastic limit is the limit or the point up to which object has retraining tendency exactly or retracing tendency exactly. So we have in this part O to A. In this region only, it retraces its path exactly. So this region is called elastic limit, or up to which Hooke's law will be valid. Abhinav, is it clear?
Yes, sir.
Breaking point is point D, and ultimate stress is point C. Good. So this is stress versus strain curve. Further, if you have to define which is more elastic, so you'll just calculate slope of this particular curve within elastic limit, that is up to point A. So this particular inclination with respect to horizontal will define you modulus of elasticity, or simply defines you the elastic behavior of substance. Next, to define ductile property, malleable property, brittle nature, just calculate or examine the length of plastic region, that is from this point to this point. And suppose if you are asked to define which is more stronger, so we'll say the more the length of or point of C, it will have tendency to withhold more ultimate stress. That will be more stronger substance. So these different questions will be asked from this part. Atif, any doubt?
No, sir.
Next is you will be asked to derive expression of potential energy stored in wire. Okay, that's it. So this is all about mechanical properties of solid, from which your question will be asked. Next is in fluid. First is hydrodynamics. First is hydrostatics. First term is pressure. So there will be some numerical on the basis of this part, whether it is on simple formula, force divided by area, or due to column of liquid, that is according to gauge pressure or absolute pressure, according to P net is equals to atmospheric pressure plus gauge pressure. Gauge pressure is rho GH. Next will be to define Pascal's law. So for Pascal's law, we have two different statements. First is for a stagnant liquid at same depth, pressure will be same in all different directions. It means it will be independent of direction of action. Second, if liquid is incompressible and enclosed in a vessel or in a container, so if you exert pressure at any one end, it will exert same pressure at the other end without changing its value. So on the basis of this statement, we have learned hydraulic lift, or which is for, or simply hydraulic brakes is also based on it. So either you'll be asked to define Pascal's law, statement of Pascal's law. You may define first statement or second statement. or you may be asked to calculate numerical on the basis of hydraulic lift. That is F1 by A1 is equals to F2 by A2. Abhinav, is it clear?
Yes, sir.
Next is Archimedes' principle. Let me define you Archimedes' principle. Suppose this is any vessel in which liquid is filled up to this point. Now suppose this is any block initially in air. So it will be experiencing force due to gravity. That is called weight. Mass of object times gravity. Mass is equals to density into volume into gravity. So this is weight of object in air. If you immerse this particular object into fluid, partially immersed and partially outside of liquid. So this is amount of volume of object inside liquid, and this is amount of volume of object outside liquid. So how much liquid this particular object will displaced? Atif, any idea?
Sir,
So you repeat?
Yes.
Sir, it will displace the same amount of water of the object which is inside, like the
Good.
same area.
That is VI.
Yes, sir, VI.
How much object has immersed into this particular liquid, it will display the same volume of liquid from it. So according to Archimedes' principle, if a body is immersed in fluid partially or completely, it experiences an upthrust called buoyant force, which is equals to weight of liquid displaced by it. So we may define this Archimedes principle as if a body immersed in fluid partially or completely it experiences an upthrust called buoyant force, which is equals to weight of body displaced by it. So we may calculate buoyant force according to this. Buoyant force is simply weight of liquid displaced. Weight is simply density of liquid times volume of liquid displaced times gravity. And volume of liquid displaced is equals to volume of object immersed into it. So it will be VI times gravity. So you may calculate buoyant force according to this expression. Now we have two different relation. First is weight and second is buoyant force. So in case of floating, buoyant force and weight of body will be equal to each other. So net force experienced by this particular object will be 0. But in case of sink, weight will be slightly more as compared to buoyant force. So we may calculate net apparent weight. So for floating condition, weight is equals to buoyant force. So apparent weight in floating condition will be 0. In case of sink, weight apparent will be actual weight in air minus buoyant force. So if you simplify this expression, you will get weight 1 minus rho divided by sigma. Atif, any doubt? Okay, you may write it down. Abhinav, done?
Yes, sir.
Okay. Next is on the basis of surface tension. You'll be asked to define what do you mean by surface tension or simply adhesive force, cohesive force. You'll be asked to define adhesive or cohesive force. Next question will be, water on surface can wet it, but mercury will not. Why? Now, related to this surface tension, there will be a question on the basis of calculation of surface tension. According to the formula, surface tension is equals to amount of force divided by length of interacting boundary. So in case of rod, in case of ring, disc, any object, you may use formula related to that part, and you will get calculated surface tension, force, and different segment related to this part. Next question will be on the basis of work done to form drop, bubble, or to convert from one state to the other state, like combination of drop or splitting of drop. So formula was work done is equals to surface tension times change in area in case of drop, but in case of bubble, it will be 2 times T delta A. Since in case of drop, there will be only one surface which is exposed to air. That's why we have 1 delta T by T delta A. But in case of bubble, there will be 2 different interacting surface which is exposed to air. That's why 2 times T delta A. Next portion will be on the basis of excess pressure. So again, we have 2 different objects. One is in case of drop and the other in case of bubble. So first question will be, towards which curvature, that is towards concave side or convex side, pressure will be more? Atif, any idea?
Sorry, sir.
Towards which curvature pressure will be more, concave side or convex side?
The concave side.
Good. So the difference in pressure in those different curvature is called excess pressure. So it is pressure inside minus pressure outside equals to 2T by R. In case of drop, but in case of bubble, Pi minus P naught will be 4T by R. Now, using this concept of excess pressure or surface tension, you will be asked to define what do you mean by capillarity, or simply capillary action or capillary rise. Abhinav, what do you mean by capillarity? Let me just define you. In a liquid, if you dip any capillary tube, very thin tube, so using the concept of surface tension, level of liquid in this particular capillary tube may rise or fall. This property or this phenomena is called capillarity. Let me define you. In first case, let's say this particular liquid is water and this is glass. So level of liquid may rise up to this point. So this is ascending case of liquid. In second case, let level of liquid remain flat at its equilibrium position. There is no rise or fall in level of liquid in this case. In third part, level of liquid may decrease to some depth, this point. Like this. In case of mercury, so we may define, if you dip any capillary tube in a liquid, level of liquid may rise or fall according to concept of surface tension. This particular action is called capillary action or capillary rise or fall. Atif, is it clear?
Yes.
So if you have to calculate how much level of liquid will rise in a particular capillary tube, let me define you. Suppose in first part, level of liquid is up to this part. So this particular liquid may be experiencing two different forces. First, due to surface tension, it must be acting tangentially along this direction. So if you break its component into two different parts, one is along this direction and then one is perpendicular to it along this direction. Let's say this is surface tension T and inclination theta. So it will be T times cos theta and it will be T times sin theta. Which surface tension will be responsible to uplift this liquid, T cos theta or T sin theta? So you'll say T sin theta, which is acting upward. This must be acting on circumference of this particular capillary tube up to this part. So we may define force due to surface tension in upward direction. So F will be equals to surface tension multiplied by length of interacting boundary 2 pi r. This entire liquid, suppose, is of height h, experiencing downward pull due to gravity. So next is force on liquid due to gravity. So F is equals to mass times gravity. Mass is equals to density into volume. Volume is pi times r square h times gravity. Now, if you compare these two expressions, you will get height of liquid will be 2 times T cos theta divided by rho g r. This is relation between height and radius of capillary tube. If you have to calculate in terms of mass, just equate mg and the above expression. So in terms of mass, it will be mass of liquid is equals to 2 pi T cos theta divided by gravity times radius. So in terms of radius and height, it will be just inversely proportional. But in terms of mass and radius, it will be just directly proportional. Atif, any doubt up to this part?
No, sir.
Okay. Now, from this part, there will be a question. Suppose level of liquid may rise up to this height h, and this tube is, in this case, is slightly longer as compared to h. So what will happen if you dip this particular capillary tube of small length as compared to h? Will the level of liquid will overflow or it will remain at its own position? What will happen if you dip a capillary tube of insufficient length or smaller length in liquid? Let me define you. You may just write it down. Last time I had defined you in some other way, like in case of pressure. Done?
Yes, sir.
My question is, suppose you have this is capillary tube. Both are same. In first part, level of liquid is up to this point. So what will happen if we dip or insert capillary tube of smaller length? Will the level of liquid or will level liquid overflow from this part, or it will remain same at its highest point? Abhinav, any idea? Let me define you what will happen. If you extend the meniscus of liquid, it will tend to acquire spherical in shape, that is in the shape of bubble. Let's say this is center and this is the radius of this capillary tube, bubble. And next is, this is the radius of capillary tube. So let's say this is theta. So this is capital R, this is small r. So cos theta is equals to base divided by hypotenuse. According to the formula, H is equals to 2t cos theta divided by rho g r. So if you substitute cos theta to be r by capital R, you'll get 2t divided by rho g, small r by capital R, small r will cancel out. So h into r is equals to 2t divided by rho into g. In right hand side, 2 is constant, capital T surface tension is also constant, rho density of liquid and g gravity, this entire thing is constant. So you can say this is constant. It means height of level of liquid and radius of meniscus of liquid, product of these two terms will be constant. So if you suppose h is very small, let's say 0. So if you substitute in this part, you will get r equals to infinite. If radius of particular curvature becomes infinite, it means it becomes flat. Hence, we can say if insufficient length of tube is dipped into liquid, so according to this height of level of liquid in this tube, a radius of meniscus of liquid will change its shape. so that it will tend to acquire this flat surface. And for flat surface, there will be no excess pressure between these two regions. So there will be no upliftment or downfall of liquid from this part. So it will stay there like this part. Abhinav, is it clear what will happen?
Yes, sir. Clear, sir.
Atif, any doubt?
No.
So this is called capillary action or capillary rise. So this is all about entire, that is hydrostatics part. You may just write it down this part. Done.
Yes, sir.
For hydrodynamics part, you'll be asked to derive the Reynolds number by giving its relation. That is, suppose critical velocity of liquid flowing in a tube depends upon three different factors: rho, diameter, and eta. So try to derive the expression of Reynolds number. Next question will be to define terminal velocity. Derive its expression. Or there will be some question related to this part, like there was a question in some test paper. I've given why helium-filled balloon on rising some height got hauled. Atif, is it clear? My question is, suppose you have a balloon filled with helium. So it will rise up to some height, and after attaining some height, it gets stopped. Why? According to the expression of terminal velocity, net force experienced by the body will be zero. So it will ascend or descend with some constant velocity. So it will be 2 times of r square divided by 9 times of eta bracket sigma minus rho times gravity. So you will say, if density of object and density of medium becomes equal, so terminal velocity of body would become zero. Only in this case, object will get stopped or get hauled in a particular position. So as we know, in atmosphere, density of air is not uniform. On increasing altitude, density of air decreases. Is it clear? So on increasing up to some height, if density of helium and density of air becomes equal, so this difference will become zero. So terminal velocity will become zero. That's why it gets stopped at that particular height. Atif, is it clear? Next, there will be question on the basis of equation of continuity. That is A1 V1 is equals to A2 V2. If area is more than velocity is less, if area is less than velocity will be more, that is rate of flow of liquid Q will be constant. And the most important part of this chapter is Bernoulli's principle. Or Torres-Lee law. So only these different questions will be asked from this part. Basically, you'll be asked to derive these expression, or there will be numerical on the basis of equation of continuity. That's it.